Earth's Evolution Through Geologic Time, presented by Jaime Airame and Abijane Rico. So before we talk about our discussion, I will be talking about our objectives. Number 1, short overview of the Earth's formation. Number 2, discuss the phases of geologic timescale. Number 3, learn more about fossil records. Number 4, discuss how human created an impact of the Earth's geology and its environment. The Earth formed over 4.6 billion years ago out of a mixture of dust and gas around the young sun. It grew larger thanks to the countless collisions between dust particles, asteroids, and other growing planets. Our home planet Earth is a rocky terrestrial planet. It has a solid and active surface with mountains, valleys, canyons, plains, and so much more. The reason our Earth is special because it is an ocean planet. Water covers 70% of the Earth's surface. Now let's talk about geologic timescale. Scientists use the geological timescale to describe Earth's history from its formation to the present day. The time span of 4.5 billion years is divided into smaller segments or units called eons, eras, periods, epochs, and ages. The entire age of the Earth is divided into 4 eons: the Hadean Eon, the Archean Eon, the Proterozoic Eon, and the Phanerozoic Eon. These 4 eons are further subdivided into eras. Now let's move on and talk about the 4 eons. Now, the first eon is the Hadean Eon. Named after the Greek god and ruler of the underworld Hades, is the oldest eon, dates from 4.5 to 4.0 billion years ago. This time represents Earth's earliest history, during which the planet was characterized by a partially molten surface, volcanism, and asteroid impacts. Now the second eon, the Archean Eon, which lasted from 4.0 to 2.5 billion years ago, is named after the Greek word for beginning. This eon represents the beginning of the rock record, although there is current evidence that rocks and minerals existed during the Hadean Eon. The Archean has a much more robust rock and fossil record. At this time, there was considerably more volcanic activity on the Earth. Its crust was beginning to cool and its flow was far greater. The composition of both the atmosphere and oceans were very different. Now, the third eon, which is the Proterozoic Eon, comes from the Greek word means early life. Modern plate tectonics became active and the ancient cores of the continents moved over the wide areas of the globe, accumulating smaller fragments of crust and sometimes colliding with other large land masses. The opposite also happened, leading to continental rifting. Lastly, the Phanerozoic Eon is defined as the current time in geological timescale. It is the era in which abundant life has existed. The Phanerozoic era covers 541 million years and goes back to the time when hard-shelled animals first appeared. Life in the early Paleozoic era was dominated by marine organisms, but by the middle of the era, plants and animals evolved to live and reproduce on land.
Hi everyone, good day. So for today's presentation, I am going to tackle about my part. So I will be discussing the different types of fossils and have a question to what I am presenting. So different types of fossils are mold, cast, petrified, carbonized, and trace. Mold fossil, when sediments bury an organism and the sediments hardens into rock. Like a mold fossil is fossilized imprint made in the substrate. Like the substrate is the rock or sediment on which a fossil makes its mark. Cast fossil, the cavity or mold mentioned above can filled in with mud. Cast fossils are like mold fossils in that they form, at least in part, with an imprint made in a rock or sediment. Petrified fossil or permineralized fossil. Minerals like calcium can soak into the buried remains of an organism. It's the mineral replaces the remaining bone and changes it into rock. Carbonized fossil. When organism parts are pressed between layers of mud or clay that hardens over time, squeezing the decaying organism away and leaving a carbon imprint in the rock, since all living things contains carbon. Trace fossil. When the mud or sand hardens into rock where a footprint, trail, or burrow was left behind. These are the most common type of fossil and can sometimes offer more information on how the organism lived than fossil body parts can. So, I have a question. What is the importance of the fossil record in understanding the evolution of life on Earth? My answer is fossils provide important evidence for evolution and the adaptation of plants and animals to their environments. Fossil evidence provides a record of how creatures evolve and how this process can be represented by a tree of life, showing that all species are related to each other. So that's all our topic. I hope you learned more about the Earth evolution through geologic time. We hope that the insights provided in the support will guide you to know more about these lessons we discussed. Thank you for watching and listening. Have a good day.